Hey everyone, welcome to the question show. Your questions, my answers. As always, wherever you are across my channel, if a question pops into your brain, just write it down. I'll gather them up and I will answer them here. Now, I'm recording this show live on Monday, April 26th, 2021. So once again, when you're seeing this, it's probably a week late. And so all kinds of interesting things will have happened. I'm guessing SN15 will have flown and landed safely. Crew will have come back from the International Space Station. The Mars helicopter will have flown for, 30th time. It's just doing great. So yeah, if you want to catch this live, I record the show every Monday at 5 p.m. Pacific time, and you can come and join and ask your questions live, and otherwise just push your comments in the chat. All right, let's get into the questions. Susie Turquoise Blue. Hey Fraser, would love to hear you talk about this. Gravity is infinite, right? So if you put two stars 100 billion light years away from each other in an empty universe with zero expansion, would the stars or their remnants eventually crash into each other? The distortions they will be making in space, that distance would be infinitesimal, right? Crazy. Yes. So when you stand here on planet Earth, you are being affected gravitationally by every piece of matter in the observable universe. So you're being affected gravitationally by the Earth, obviously, by the sun, by all the planets in the solar system, by all the stars in the galaxy, by all the galaxies in the universe. You're experiencing the gravity, I guess, of the Big Bang itself. And so no matter how far you go, because gravity moves at the speed of light, eventually the gravity will reach every destination. And so, yeah, if there was just like two stars, two oranges in space, maybe they wouldn't survive very long. And there was nothing else in the entire universe. So nothing else was interacting gravitationally. Those two objects would reach out as far as the speed of light, speed of gravity had taken them, and they would start to pull each other towards each other. And eventually, if you waited long enough, I have no idea how long it would be, a very long time, those two objects would collide with each other. So yeah, you are affected gravitationally by everything in the universe. Joyful Running. Hi Fraser, I have a question. Do we know how deep the lunar regolith goes before you reach bedrock? I guess it will vary, but do we have any idea of the minimum or maximum regolith depths? Thanks. This is a great question because this was one of the scientific questions that China's Chang'e 4 lander and rover were going to try to answer. So the mission was equipped with a ground-penetrating radar scanner, which is not a thing that NASA has equipped with any of its current rovers. And so its job was to sense the depth of the regolith. And so right now, this was the mission that landed at the moon's south pole. And so it was able to use this radar to essentially scan the regolith beneath its feet. And what it found was that for the first few meters, it was just this powdery regolith. And then as you went deeper and deeper, the chunks got bigger and bigger until they were essentially boulders of regolith. And so, it kind of makes sense that you've essentially got these big fragments that are blasted out by these large impacts, and they rain down, and then the smaller pieces fall down on top of them and fill in all the gaps and make a powder on the surface, and eventually the smallest stuff is on top of it. So where does it go from regolith to bedrock? Yeah, it goes dozens of meters down below. So yeah, it's kind of amazing. And again, like, this was a scientific question that we didn't know the answer to, and it just came in the last couple of years, which was great. Jolly Blonde Giant. Hey Fraser, is it possible that nearby star systems contain Earth-like planets that we haven't detected yet due to the limitations of our current methods? Yeah, absolutely. Almost certainly. All of the planetary systems that we have detected so far, and all of the star systems that we know of, almost all of them are going to have planets that we don't know about, of varying sizes. And when you think about the way planet finding works, is that you're essentially finding the extremes. You're finding the stuff that is the most massive. And so when you think about, like, say, the first exoplanet was discovered back in 1995, Peg 51, and it was this giant Jupiter-sized planet orbiting around this star so closely that it was yanking the star back and forth, and so astronomers were able to detect its presence. It was at the very extreme. And then as the astronomers refined their technology, as they developed new missions like TESS and Kepler and some ground-based observatories, they were able to find smaller planets farther from their stars, and so on and so forth. But you're still experiencing just this fraction. And another big part of it is that the main methods of finding planets right now, the radial velocity method, where you essentially measure the gravitational yank of a planet as it orbits around the star and sort of pulls it back and forth, or the transit method, where the planet passes directly in front of the star and dims it briefly as it passes in front. Both those require the star and the planet to be perfectly aligned in our point of view. And that really only counts for about 1% of the star systems that we can see. And so when you think of it, like, there's lots and lots of other star systems out there that aren't aligned, that we're looking at them sideways, we're looking at them at an angle. And so we just don't have an easy way to detect those planets. But there's new technology coming along, like the extremely large telescope in Chile, which is going to be able to do direct imaging of exoplanets. And there's going to be other ones coming as well, James Webb a bit, and then things like LUVOIR, et cetera, into the future. And there's other techniques, like Gaia, using astrometry to sort of measure the little circle that a star does in the sky as a planet is orbiting around it. So over time, we will fill in the star systems with the planets that we didn't know about. We'll fill in the additional planets in these star systems and get a much better census. So right now, it's really just the beginning of exoplanet discovery. There are many more, millions, billions more planets for us to find. Nuno Pereira. A Perseverance image has shown Ingenuity's solar panel 25% covered with dust. How can it diminish its performance and how to remove it? Yeah, this is the challenge that all the solar-powered spacecraft that go to the surface of Mars have to face, is that there's this fine dust in the atmosphere of Mars that percolates out and falls on the top of the solar panels of all of the spacecraft. And this was considered the thing that was going to wipe out Spirit and Opportunity, which were the smaller rovers that went before Curiosity. And they were expecting they would have about a 3-month life, and then the solar panels would be clogged with dust, and then the rovers wouldn't be able to power themselves up anymore, and then they would get cold overnight, and they wouldn't be able to save their batteries, and so then they would go offline. And what happened was there were these cleaning events. And NASA's not still 100% sure exactly what's going on. One idea is that they're dust devils that are flying over and blowing off the dust on the solar panels. Another idea is that there's sort of statically charging events that sort of raise the dust off of the solar panels and fire them sideways. But whatever the case, these things were happening with a regular enough basis that it was keeping the rover solar panels clear of dust and allowing them to operate for years instead of months. And now, I mean, this is sort of a thing that NASA counts on. And so we're watching as InSight is getting more and more clogged with dust. And so it's having to shut down its operations while it waits for one of these cleaning events. And then it could very well happen that the Ingenuity helicopter is going to have its solar panels cleared off, and then it's going to be able to fly. Or may get to a point where it's too much dust and it can't fly, and then it has to wait for another cleaning event. And the worst case scenario is that the solar panels will get covered in dust. It'll get cold at night. It won't be able to keep itself warm enough. Its battery will fail, and then that'll be that. But going into this, NASA really didn't expect more than about a month's worth of flight time, like a few dozen flights at the most, and then this would be considered a successful test for future missions to have a more robust aircraft go to Mars. So if it gets clogged with dust and it can't fly, then we just hope that it'll happen again. But you can imagine with it actually sort of shaking and flying, and even sort of moving a bit through the air, maybe they'll come up with some clever ideas like make it fly really fast. But the downside is the atmosphere on Mars is so thin. It's 1% the atmospheric density of Earth. You know, I've mentioned this several times. You know, you can't fly a kite on Mars. You could stand out in hurricane speed winds on Mars, and you couldn't even fly a kite because the amount of air that's rushing against you is so low. So who knows? We'll see what happens. Maybe they'll spin it really quickly and then the centrifugal force would throw the dust out. I don't know. We'll see. I look forward to their creative solutions. Joe, is there a difference between microgravity and zero gravity? They're the same thing, but people use microgravity as a more accurate term because, as I mentioned at the beginning of the show, you are experiencing the gravity from every single object in the entire universe. So there's really no place that you can experience zero gravity because you will always be experiencing gravity unless you left the universe. You're experiencing gravity from, again, as the astronauts are orbiting the Earth, they're still experiencing about 90% of the gravity of the Earth that you would be experiencing if you're down on the surface. The trick is that they are falling. They are going around the Earth so fast that as they're about to hit the ground, they miss the Earth and they just keep going around and around and around. And so when you're in that situation, you experience a balancing of the forces. You're experiencing the force of gravity that's pulling you down, and yet the spacecraft is essentially falling around the Earth with you. And so compared to the spacecraft, you experience no gravity. And it would be the example of, like, say, being in an elevator, right? That the elevator fails and you fall and you're inside the elevator. And so from your perspective, you're floating around in microgravity inside the elevator. But the reality, of course, is that you are experiencing the gravity, you're falling towards the Earth. So that term microgravity sort of gets around this idea that you're experiencing zero gravity, which is why it gets used. Lord of Entropy. Do you think that the recent hinting by the Russians about ending their part in the ISS after 2020 for a shakedown of sorts? And if they were to leave, who, if anyone, might step in to fill that void? Now, I've been doing this job for a long time, and the Russians have threatened to leave their portion of the International Space Station several times in the past. In fact, there's been a couple of times where they said they were going to be leaving it. NASA and the Russians negotiated. They extended the date to, I think, even to like the 2024 or 2028. And so you get these extensions. But running the International Space Station is expensive. Flying people up to the station is expensive. And the Russians and the Americans are having a increasingly testy relationship. And so it makes sense that the Russians are looking to maybe partner up with another nation that they have better relationship with. But they've made this threat before and then recommitted to working on the International Space Station. Will they actually do it? I mean, the space station itself is getting older and getting more expensive to maintain, and every new astronaut has to spend a little more time on the station, keeping it going, fixing equipment, trying to sort of keep the whole machine going. And eventually, both the Americans and the Russians will come to the conclusion that it's time to deorbit the International Space Station, and so they'll do that. It would be sad because I think I really like the partnership between the Russians and the Americans with the International Space Station. It's just this, I have so much respect for the Russian space program, what they did in the past, what they were capable of, both in planetary exploration as well as human space exploration, and what a sense of pride and honor it must be for them, for people in Russia, to be a part of that program. And there's been more recently, a lot less emphasis from Russia in new space. They make a lot of plans. Went back, I could, we're going to send people to the moon. We're going to send people to Mars. We're going to, there's been tons and tons of things that the Russians have said they're going to do, and none of those plans have panned out. But the thing they have done is launch Soyuz, help complete the International Space Station, and sent tons and tons of cosmonauts up to the station to participate in the science. And so I think it's been really good for humanity that the International Space Station exists. And it would be my hope that the moon has an international moon village and that missions to Mars are an international mission. The more we work together, the less we feel the need to fight, and that would be my preference. Dylan Chapman. Wouldn't the expansion of space be greater than the effect of gravity? Yes. Well, sort of. The universe is expanding as this process left over from the Big Bang. All of the galaxies are experiencing this leftover momentum from the Big Bang, and they're all sort of expanding away from each other. And the accelerating force of dark energy is making this expansion happen even faster. But all of these galaxies are still experiencing gravity from each other. They're still connecting. It's just that the outward force is stronger than, the force that is pulling them apart, and as well as just that momentum. The gravity is like the universe trying to put the brakes on all of these galaxies flying away from each other, but it's not enough to slow them down. And so the galaxies are going to end up flying away from each other. So the gravity's still there. It's just that it's not enough. And in fact, 20, 30 years ago, when you had some of the original cosmic microwave background radiation missions like COBE or WMAP, one of the goals was essentially to measure the curvature of the universe. And they were trying to figure out whether the universe was open, that it was going to essentially expand forever, whether it was closed in that it was going to sort of, all that mutual gravity was going to attract each other, and eventually the universe would come back into another Big Bang, or whether it was flat, where the universe would keep on expanding and coasting perfectly to a halt at some point at infinite time. And what they found was that the universe is flat. And then they discovered dark energy, which told them that, in fact, not only is the universe going to expand forever, it's accelerating, and so the expansion rate is going to pick up speed. Fool Creations. Hey, Fraser, what would be the biggest exoplanet that we could live on? So when you're sort of thinking about the size of the exoplanet, the thing that would define whether or not we could live on it really would be the surface gravity. How much gravity are we experiencing on the surface of the planet? And the surface gravity that you experience comes from essentially two numbers. You measure the mass of the planet, you measure the size of the planet, you get those two, you get the density, and you get the surface gravity. And so you would think that if you say doubled the mass of a planet and doubled the size, you would sort of have double the gravity. But you actually don't, because the density goes down when you double the size, you double the gravity. In fact, it would only go up a little bit. Like, I forget the exact number, like 1.2 or something like that. And so it really just depends on what the planet is made out of to define sort of how much extreme gravity you would have. But I think for us as human beings, and even just for life on Earth, even a slight increase in gravity for surface dwellers would be hard on our bodies. The elephant, the us, insects, everything on Earth has sort of evolved under this very set gravity. And so if you increase the amount of gravity, even like a little bit, life would have a hard time surviving. And so you can sort of imagine what could be a future maximum gravity just for life itself. And so if you had creatures that lived in the oceans, they would be able to handle significantly higher gravity because they'd have this neutral buoyancy. But if you had something that was trying to live on the surface, maybe you get to a point where you've got, say, double gravity, and things are very stout and they have to crawl around on the surface and they can't grow very big. But a thing that's kind of interesting is that if you had double the gravity, you would actually have a vastly thicker atmosphere. And so flying would become a lot easier on a place with higher gravity. You could fly through the atmosphere. And so you might have a weird planet with squat little creatures and yet an amazing diversity of flying creatures. It would be pretty amazing to see. More questions in a second, but first I'd like to thank our patrons, Dennis Armstrong, John Carey, Trey Harmon, and the rest of our 850 patrons for their generous support. Want our videos early with no ads? Join our community at patreon.com/universetoday. T. Crenshaw. What do you think about MOXIE, and how big of a role do you think it's going to have in future missions to Mars? So MOXIE is an acronym, and I forget what it stands for. but it's like Mars, atmosphere, oxygen extraction, something like that. And what it is it's an experiment on board the Perseverance rover that's designed to pull in the atmosphere of Mars, the carbon dioxide atmosphere of Mars, and split it to be able to create oxygen, like pure oxygen, that then astronauts could breathe or could be used for rocket fuel or all kinds of things. And MOXIE has worked great. It's been able to extract I forget the amount, not a lot, a few grams of oxygen, enough for an astronaut to breathe for like 10 minutes, but it proved that this works. So now we know that this fairly small box can generate oxygen over long periods of time, and you could scale it up and send a bigger instrument like MOXIE, or maybe you could just run it for longer. And so the ability to create the resources that you require for your mission in situ is fantastic. And so this sort of shows a lot of hope. But I think this also just shows how difficult and complicated it's going to be to try to send human explorers to Mars for long periods of time. Like, this is just one little piece of the puzzle. Can we make oxygen for them, for their rocket on the surface of Mars? Turns out, yes. Now, how do we store it? How do we pump it around? How do we deal with it in the low gravity? What if it leaks? How do we mix it? Where do we get the hydrogen from? Where do astronauts go to the bathroom? Et cetera, et cetera, et cetera. Just the details just go on and on and on as we try to think about what it's going to be like. And so we have to sort out, we have to send prototypes for all these little pieces in advance. If you want to do this safely, I mean, obviously, if you want to do this unsafely, just send a Starship with a bunch of people, roll them out onto the surface, and let them fend for themselves on the surface of Mars. But I think if you want to do it responsibly, you have to figure out each little piece of the puzzle, come up with a prototype, test it on the surface of Mars, learn from your mistakes, iterate. And so this is a great example of the kinds of experiments that need to go to Mars sooner than later. Chris Sanders, do you think that humanity will need to cure cancer for long-term space travel and habitation? Like, if that's what it takes, if people want to go to space and so someone says, let's cure cancer, that would be fine. I mean, I can think of all kinds of reasons why we should cure cancer. Cancer's the worst. Like, we should cure cancer so that our friends and family don't have to die of cancer. So out in the void of space, when you're outside of the protective magnetosphere of the Earth, you're experiencing dramatically increased amounts of radiation. You got the solar radiation that's coming from the sun, and you have solar storms that can boost those levels to lethal levels. But those are relatively straightforward to defend against. The one that's really tough is the cosmic rays. And these are really energetic particles that are coming from all across the universe. They have enormous amounts of energy, and they're almost impossible for us to stop with any good technology. And it's just coming from everywhere. It's raining down all the time. And the solution to that is mass, protons. You put water, you put metal, you put regolith, something in between you and all of that stuff. And I don't think that that's going to be anything that's going to stop anybody. We're just going to take asteroids, hide inside them, mine asteroids to build structures that provide mass to what we need. So there's plenty of raw materials out there. It's just a matter of learning how to work with them in the microgravity of space or long periods of time to be able to fashion them into what we need. The first explorers, the first colonists who go to places like Mars are going to have to just accept the reality that as they fly there in space, they're going to be taking an enormous radiation load, and it's going to increase their chances of cancer down the road. But I think there's plenty of people who are fine with that being the consequences. It's not like you're going to get cancer immediately. It's like you're going to get cancer 30 years later. So I think for a lot of people, that's a risk reward that they're willing to take. And there's a lot of things that we can do to mitigate it, to go fast, try to provide radiation shielding as much as you can, and then hide underground when you get to your destination. But for the long term, yeah, we're going to have a way to have a meter of water in between us and space. Like that's, or an equivalent amount of rock or an equivalent amount of metal. Like that's going to need to be the solution in the end that keeps us safe while we're in space. What's next? With all the YouTube channels dedicated to space exploration, why is no one serious about YouTube-funded private missions? Space is incredibly expensive. If you want to buy a flight on a Falcon 9 rocket, you need to spend about $60 million. If you want to fly on a Falcon Heavy, it's $90 million. If you want to buy, like, say, a Delta launch or an Atlas launch, then you're looking at hundreds of millions of dollars. Space is incredibly expensive. I mean, maybe there's some YouTubers out there. Maybe PewDiePie could pay for and organize a space mission, but then what's the benefit that you get from it? Because the other side of it is that there is nothing profitable that you can do in space except for applications that relate to Earth. So if you want to launch a communications satellite array like Elon Musk, you could make a profit from that. If you want to launch weather satellites, maybe. If you want to do Earth imaging, radar, if you want to provide a GPS system, then you can make some money from that. But if you want to try and do like asteroid mining or habitation, you will run out of money and go bankrupt like they all do. I don't know, there was like a thing called Mars One a couple of years ago where they were trying to kind of do something like that, where they were trying to crowdfund and they were going to make the show rights. They were going to sell the rights to the stories that were happening and make money from that way, and it went out of business. So right now it's just too expensive. But I think, in the future, we're going to see the costs come dramatically down, say with Starship, where maybe you can build and launch a satellite for $10,000, $5,000. I mean, satellites themselves, you can make CubeSats that cost just a few $1,000s at this point. And then the launch costs are, say, double, triple the cost of the satellite itself. Maybe we'll get to a point where launching a CubeSat is relatively inexpensive and more people will get a chance to launch satellites. So if you want to organize a crowd-funded space exploration program, nobody's stopping you. Ben Kalo. ISS residents always have to answer the same dumb questions about sleeping, eating, using the toilet in space. What do you think the astronauts' own big questions are? I mean, astronauts are people. They're highly skilled people with a tremendously varied background. When you get a chance to talk to astronauts, and I'm like so fortunate that I've been able to have like really long and meaningful conversations with a lot of astronauts, you just get a sense that they're passionate about, say, flying airplanes or photography or science, and that was what they were first. And then they applied to become astronauts. And so if you look at every single astronaut, they have some background as a test pilot or as a scientist or in some other level of expertise. So, I mean, what are their big questions? I mean, they're going to have different questions, right? Like when I talked to, say, Don Pettit, he was really interested in photography and trying to capture the experience of being on the International Space Station and looking out the window and seeing the Earth roll under you and being able to turn that into something that he could communicate and share with the world. And I think he did a great job. Others, I think, experience, sort of deeply meaningful spiritual experiences when they're on the space station or on the moon. There's this idea of the overview effect, that when you see the Earth from above, you sort of stop seeing it as separate countries. You just start seeing it as this one place that needs to get its act together and work together. I mean, I know this is a bad answer, but the thing is that astronauts are sort of like, they're people first with their wide varying career who then apply to become an astronaut as sort of the culmination of that career, not necessarily because that's what they were planning to do all their life. And so it's kind of amazing how much variety they have. And I think NASA and others do a bad job of showcasing how different they are. And I wish that we could have a better experience. Like I wish more of them were YouTubers or were on Twitch and sort of shared more about what it's like to be an astronaut and just what they're about, because I think that would give us a better connection to who they are and what an impact they're having on spaceflight. Christian Lockman. Could there be the same type of balloon-like habitat on the gas giant planets like there could be at Venus? So, we've talked about this several times, I think, in the past, that one of the cool things about Venus, even though the surface of Venus is the worst, 450 degrees Celsius down on the surface, pressure 90 times greater than Earth pressure. It's like being under a kilometer of water, as well as sulfuric acid rain. It's the worst. It's awful. Don't go there. Don't do it. But as you get higher and higher up into the cloud tops, you reach this point it's about 75 kilometers up, where the temperature is room temperature, where the pressure is Earth pressure, and you could stand outside on Venus without a spacesuit. You just need a breathing apparatus because it's still carbon dioxide and possibly with a mix of sulfuric acid rain. And one of the cool things is that just breathable Earth air, so the mix of oxygen and nitrogen, is a lifting gas on Venus. And so you could build a balloon out of just the air that you breathe on Venus, and that would be your city, and you could float around in it and stay protected from the worst that Venus has to offer. And so the question is, could you take that to Jupiter or Saturn and do the same thing? And the problem is that the atmosphere of Jupiter and Saturn, they're made of hydrogen and helium. Now you've got some ices, some ammonia, you've got some other stuff on the outer edge of this planet, but essentially they're hydrogen and helium. And so you need something that's lighter than hydrogen to be able to float in hydrogen. And pretty much the only thing that's possible to do that is heated up hydrogen. So if you made your blimp and filled it with hydrogen gas, which on Jupiter wouldn't be quite as dangerous as it would be on Earth because it wouldn't be flammable there, and you heated it up, then you could theoretically be able to get some kind of altitude where you could float around, but it would be really hard. The gravity is quite intense on Jupiter, and you would have a hard time ever escaping again if you tried to get out of that gravity well. So I don't recommend it. I think we'll be living on Venus for centuries before we try to do anything like that on Jupiter. But there is an idea that's pretty cool, where what you do is you essentially take like a rocket engine, a fusion rocket engine, and you have it suck in hydrogen fuel from Jupiter and blast out that fuel as a rocket engine on the bottom of it. And then you can just sink it into the atmosphere of Jupiter, and it will be sucking in fuel from Jupiter, blasting with this rocket, and be able to maintain its altitude in this way. So if you could build a fusion rocket and take it to Jupiter, and you could miniaturize it and make it all work, you could theoretically have a floating city on Jupiter that's constantly firing these fusion rockets to stay in place. So that's a pretty cool idea. Noah Silber, how would we produce enough power on Mars? I saw to reload one Starship for a return trip with solar power would take 25,000 square meters or 4 football fields worth of solar, plus life support systems. Yeah, power on Mars is a huge problem because you're farther away from the sun. And so the solar panels have to be, if you're going to use solar power, which is possible, they have to be much, much larger than they have to be anywhere near Earth to be able to produce the same amount of power. So if you want to live on Mars, you are going to be power starved. And there was an interview I did a couple of months ago, and he was saying like the most important thing in space, the thing you need the most is power. And the second thing that you need is power. And the third thing that you need is power. That the three most important things that you're going to need when you're going to go to space are the things that are hardest to get on Mars. Now, the other idea is nuclear. So NASA is working on this nuclear engine called the kilopower, where you would essentially take a fission reactor. And, because right now, say Perseverance and Curiosity, they've got this plutonium RTG reactor on board. It's really just they're taking the heat that's coming from this decaying plutonium and then turning into electricity is very inefficient. But if you actually use a fission reactor, you could produce thousands of watts of power using the same amount of plutonium. So, and there have been, the Russians launched dozens of fission reactors into space. The Americans have launched one, at least. So it definitely works. And so probably the future of power on a place like Mars is going to be fission reactors. Until later on, well, there isn't any real hydrogen that you can get access to on Mars. You won't be able to use fusion reactors. So it's going to be fission. They're probably going to have to import most of this stuff from Earth. It's going to be tough. Solar panels will be tricky. And as you said, it's going to be just football fields of solar panels to be able to supply the amount of energy that you're going to need to do even just very basic things. It's going to be a big problem. And I'm sure people are going to try and solve it. Sparky Man. Hey Fraser, Elon Musk said Artemis' 2024 goal is very doable. Do you think the chances have grown because of SpaceX, or will it likely still be delayed, and if so, how long? Yeah, I think SpaceX's involvement in the Artemis program to provide the lunar lander, which is just ridiculous. It's an entire starship, a cavernous starship, was the cheapest, best solution to provide a lunar lander. Like, I just imagine you just sort of take the Apollo, you take the capsule and you just sort of go inside the Starship dock, and then the whole thing just lands on the moon. It's crazy. That's not how it's going to work. They're going to dock with it, transfer to some crew module inside the Starship, and then go down, and then Starship's going to fly back off. It's elegant. We've seen this thing do that. We know that these Starships can do that takeoff landing thing. It should be a lot easier with no atmosphere, where it's just entirely a propulsive landing to go from lunar orbit down to the surface. So that all seems really doable to me. And I think, yeah, getting SpaceX and Starship involved was the absolutely right move. And I think the thing that's holding it up is the Space Launch System. Instead of building Space Launch, they should launch on a Falcon 9 with the Crew Dragon and have the Crew Dragon, sort of an upgraded Crew Dragon, do the flight to dock with Starship, and then Starship takes the astronauts down. Like, they could make it even more feasible. Like, Crew Dragon flies, it works. To upscale it, to be able to go to the moon, that's doable. So yeah, I think the announcement that was made to get SpaceX involved and to provide the lander for the Artemis program was sort of the first step of what is going to be this shifting of perspective in the US government and in NASA in how they're going to be able to make their future missions work. And I wouldn't be surprised. I would not be surprised if SpaceX gets so good at this that they will offer a per seat price to just drop astronauts off on the surface of the moon and bring them safely home to Earth. And so NASA will go from having all this infrastructure to literally just, they pay a ticket and they pay for return flights from the moon. And it'll be some, expensive price, like $1 billion per astronaut, but it will still be far cheaper, far more feasible than running the whole Space Launch System and all the infrastructure and designing all the pieces along the way. Like we are seeing this shift into trips to space provided as a service, which we can do in every other part of the world, right? You want to fly to Europe, you pay for a plane ticket. You want to move somewhere on the ground, you buy a train ticket, you buy a subway ticket, you rent a car, you get an Uber. Like, it just makes sense. All right, well, those are all the questions that we had this week. Thank you, everybody, for joining me for the live show, as well as asking all of your questions across the chat. Remember, as always, if a question pops into your brain, just write it down, and I will gather them up, and I will answer them here. If you want a single comprehensive resource for space news, you'll want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights about the story, and links so you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. And did you know that all of my videos are also available in a handy audio podcast format? So you can have the latest episodes, as well as special bonus material like interviews with me, show up on your audio device. Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. And I'll put a link in the show notes.